In this video, we'll be going through the multiple choice questions from the 2021 HSC Mathematics Extension 1 exam, and hopefully this will be the first of 5 videos covering the entire paper. So let's get straight into it. Question 1. Given that vector OP equals -3, 1 and OQ is 2, 5, what is PQ? So here we've been given 2 position vectors, and we need to find the displacement vector PQ. In order to do this, we recognize that PQ is the same as OQ minus OP, and so we're simply subtracting those 2 vectors. 2, 5 minus -3, 1. We subtract component-wise, which gives us 2 minus -3 is 5, 5 minus 1 is 4, which gives us option C, and that's that one. The next one, which of the following integrals is equivalent to the integral of sine squared 3x dx? So in the Extension 1 course, integrating sine squared and cos squared is something unique to the Extension 1 course that's not in advanced. And there is a formula on the formula sheet which helps us deal with questions like this. And I believe it is given as sine squared nx is equal to 1/2 1 minus cos 2nx. And so here in our scenario, n is simply 3. And so we will basically be substituting 3 into this. So if I want the integral of sine squared 3x, that's equivalent to integrating 1/2 1 minus cos 2 times 3, which is 6x. And that obviously is the same as option B. Okay, so we can circle B. Okay, question 3. What is the remainder when p of x equals negative x cubed minus 2x squared minus 3x plus 8 is divided by x plus 2? So we're trying to find the remainder when we divide by a linear factor. And so this comes down to simply substituting in this case, because x plus 2 is the same as x minus -2, the remainder is found by substituting in -2 into our polynomial. This is the remainder theorem. So our remainder is going to be equal to p of -2, which is -2 cubed minus 2 times -2 squared minus 3 times -2 plus 8. This is a scenario in which you can simply substitute it into your calculator, but you would really need to be careful about having your brackets in the right spots here. So this would give us, let's see, that would be a positive 8 there, minus 8 plus 6 plus 8, which gives us 14. So option D. Question 4, we consider the differential equation dy on dx equals x on y. And we want to see which of the following best represents the relationship between x and y. So essentially we're trying to solve this differential equation. It's separable, so it's solvable using the techniques that we learn at school. So let's go ahead and do that. I want to get all of my y's on one side, all of my x's on the other side. That's what it means for it to be separable. You can separate out the x's and the y's. So we would get y times dy equals x times dx. And then I'm able to integrate both sides. And I would get y squared on 2 equals x squared on 2. And I need a plus c on either side. It doesn't really matter which side. I'm just going to put it on the right-hand side here. Get a plus c. And I have a look at my options, and none of them look exactly like what I've got, but that's okay, because if I just multiplied this entire expression by 2, I would end up with y squared equals x squared plus 2c. Now still this doesn't look exactly like any of the options, except it really is the same as option A, because 2c is itself just a constant. If c is a constant, then 2 is itself a constant. And so I can think of this thing that I've circled in green, this 2c, as simply being a constant. And sometimes we even just write it as c. And the phrase that we use is that the 2 gets absorbed into the constant. It's lost into the constant. And we have that expression there, which gives us option A. All right, question 5. For the 2 vectors OA and OB, it is known that OA.OB is less than 0. Which of the following statements must be true? Okay, so let's read them. Option A says either OA is negative and OB is positive, or we have OA is positive and OB is negative, well, that makes no sense whatsoever because a vector isn't positive or negative, right? So that's obviously not correct. We can cross that one out. Option B says the angle between OA and OB is obtuse. Now this one is plausible. This could be the answer, so I'm going to not eliminate that one yet and keep going. C, the product of the magnitude of OA and the magnitude of OB is negative. Well, a magnitude is talking about a length, and a length is always positive. So something positive times something positive can't give me something negative. That one's obviously incorrect. Option D says the points OA and B are collinear. Okay, so let's draw up a scenario where they're collinear. Let's say this is O, perhaps this is A, and this is B here. And so the vector OA looks like that, and the vector OB, if I go over this in blue, looks something like that. Now, if I was to take the dot product of those two vectors, they're pointing in exactly the same direction. So what I could even do, I could say OA dotted with OB is equal to OA dotted with a scalar multiple of OA, because OB is in the exact same direction as OA, it's just a different length. And then, okay, I can move my K out the front, and I've got OA dotted with itself. But any vector dotted with itself is the length of that vector, or the magnitude of that vector squared. And since they're pointing in the same direction, this K, I should have probably stated this earlier, this K here has to be positive, because if it was negative, they'd be pointing in opposite directions. So perhaps I should have said this up here, K has to be positive. And so I've ended up with something positive times something positive, which means that this has to be greater than 0. So it's not necessarily true that if they're collinear, that their dot product of OA and OB is less than 0. So this option is incorrect, which leaves option B as the only remaining option. However, it's interesting to note that this is actually also not necessarily true. And I believe that this is a mistake that NASA made in the question, because OA.OB less than 0 happens if we have precisely this sort of scenario. So let's draw it up. If we had O here, and we had A here, and we had B here. So OA is going like this, OB is going like this. And so the angle between these two is 180 or pi radians. So we can mark that there. We have pi radians. And so if we were to use our dot product formula, OA dotted with OB, that's the length of A times the length of B times cos of the angle between them, cos pi. Now cos pi, or cos 180, is -1, and so I know that this is negative the length of OA times the length of OB, but this is a positive quantity, that's a positive quantity, and I'm multiplying that by something negative. So overall this is negative. So here we've come up with a case where OA.OB is negative, so this has been satisfied, but the angle between these two is not obtuse. 180 degrees is not an obtuse angle. An obtuse angle is only one that runs between, strictly between, 90 and 180. Okay, or if you're talking in radians, pi on 2, and pi. This is a strict inequality, and so that means option B is actually also not always true. But I believe it's the least wrong of all of these options, so I would go with option B. Okay, question 6. The random variable x represents the number of successes in 10 independent Bernoulli trials. The probability of success is p equal to 0.9 in each trial. It says let r be equal to the probability that x is greater than or equal to 1. So what's the probability, in other words, of having one or more successes? And we want to find the value of r, or which one of these, rather, best describes the value of r. Okay, so I want to try to work out something about the value of r. Let's write down what r would be. Well, it's all of the cases where x is greater than or equal to 1. So it could be 1, 2, 3, 4, 5, 6, 7, 8, 9, or 10. Now, working out each of those individual probabilities is a bit of a hassle, and so we use complementary events to simplify our work. So r, which is the probability that x is greater than or equal to 1, is also equal to 1 minus the complementary event, which is x equal to 0. That's the only other event. That's the only event actually that's not included in that range there of x greater than or equal to 1. So 1 minus the probability of having no successes. Well, what would that be? This is a binomial probability kind of question. So it would be 10 choose 0 times success happens 0 times, and failure, which is 0.1, happens 10 times. Okay. Of course, you could have just written this because you know there's only one way that you have no successes, which is that you just have all fails. But anyway, you plug this into a calculator and you get something like 0.9999, not sure, maybe 5 times or something like that, or many times like that. And then we see which one of these options does this suit, and it looks like it suits option A. And so that's going to be our answer there. Okay, the next one. Which curve best represents the graph of the function f of x equals minus a sine x plus b cos x, given that the constants a and b are both positive? Okay, this is an interesting one. The very first thing I would do is try to work out what kind of information can I determine about this function. Are there any actual function values that I would be able to work out? And I think the one that's easiest to determine would be f of 0, because substituting 0 into this actually tells me something about my graph, whichever one it is. It will tell me something about it, and that is the y-intercept. Okay, because when x is 0, that's when we get our y-intercept. So if I sub in f of 0, I might be able to fit it in here. F of 0 equals minus a times sine 0, well, sine of 0 is 0, plus b times cos 0. Cos of 0 is 1. So I've got 0 plus b, which is simply a b. So what I know is that f of 0 is b, but that doesn't really help me because I don't know what b is. But it actually does, we do know something about b. We know that it's positive. So that's useful because I know my y-intercept has to be positive, which means it's either going to be option B or D, and so I can eliminate options A and C. So I cross these ones out, and I'm left to determine whether it's B or D. Now let's try to think about what's different about B and D. Now, I can't really work out much about the other points. Or when I say other points, other x values is what I should say, because I don't know what this value is here or this value. So it's a bit hard for me to work out x-intercepts. That would be setting y equal to 0, and I don't know much about a and b compared to each other. So I don't think that's the way to go. But one thing I do know is that there is something different about these intercepts, these y-intercepts here. One of them has a positive gradient, sloping upwards. The other one has a negative gradient. So maybe that's a way that I can differentiate between the two. And that's a little bit of a pun there, because what we're actually going to do is we're going to differentiate this function to get the gradient function. And then the gradient function, once we plug x equal to 0 in there, will tell us whether it's going to be positive or negative gradient. So differentiating f dash of x gives us minus a times cos x plus b times, that should be minus sine x. And now I want to plug in 0, so f dash of 0, to tell me what the gradient is at x equal to 0. In other words, what's the gradient at the y-intercept? So we get minus a times cos of 0, which is 1, plus b times negative sine 0. Well, sine 0 is 0, so negative sine 0 is also 0. And so I end up with minus a. And since a was positive, we're told a is positive, that means f dash is negative. So this tells me then that f dash of 0 is less than 0. And so which one of those has a negative gradient? Well, clearly we can see that this has a negative gradient there, this has a positive gradient. So B is incorrect, and we're left with D as the correct answer. Okay, question 8. The diagram shows a semicircle. Which pair of parametric equations represents the semicircle shown? And so we're given a lot of options here, well, 4 options. And let's try to see if we can notice what's different amongst them. So for each of them, we've got, should do that with a laser. For each of them, we've got the same domain restriction on t. So that's probably not going to be the thing that separates them. It still is going to be important, but it's probably not going to be the thing that separates them. Now looking at options A and options C, they have something in common, which is that sine is appearing in the parametric equation for x, and cos is appearing in the parametric equation for y. That's differing for options B and D. So it's flipped for B and D. For B and D, we have cos appearing in the parametric equation for x, and sine in the equation for y. And then amongst these two, amongst A and C, obviously we've got a plus here and a minus here. Same sort of thing for B and D, a plus and a minus. Okay? So, what can we say about this graph here, this semicircle that we've got? Well, one thing that we can write down is its domain and range, because it's easy to just simply read off. We've been given this point is 4, 2. This is 2, 2, and this is 3, 2. So obviously the radius is 1 unit. So I go across one like that and across one like that. And so my domain here is going to be that x runs between 2 and 4. But then, because it's a semicircle, I know that I go down 1 unit as well. And so my range is going to be that y runs between 1 and 2. Now this is going to be something that's quite helpful. Okay, now, why is that going to be helpful? Because that's going to help us determine which of these is correct. And how's it going to do that? Well, we know that t is always running between minus pi on 2 and pi on 2. So, minus pi on 2 to pi on 2. I would like to find out something about what values sine ranges between, if t is ranging between those values, and similarly what values cos ranges between if t is ranging between these values. So, I want to find out what sine goes between, and I want to find out what cos goes between. And the reason I want to do that is because if I can find a range of values for sine, then that might help me to determine whether I'm going across a certain amount, if it's appropriate for sine, or if I need to be going across a certain amount with the restriction on cos. Okay, so that's one reason. And then the same thing is I can also determine how much I need to be going down by for y, and I'll see which one of these two matches up with it. Okay, so if t ranges between the values of minus pi on 2 and pi on 2, what does sine of t range between? Now here it's very tempting to just take the sine of each of these parts here. Okay, sine of each of those 3 parts of this inequality, and actually it would work for sine. It would work for sine. I'm going to do it. I would get minus 1 and 1. So it works for sine, but I will explain why it works in a moment, because I don't want us to just think, all right, it worked, but not understand why. It's not really, I don't want us to think of it as a fluke, okay? But notice what would happen if I did the same thing for cos. If I said cos of each part of this inequality, well, cos of negative pi on 2 is 0, and cos of positive pi on 2 is also 0. And so this is telling me that cos of t basically can only be 0, which is incorrect. So the best way to think about something like this is to actually draw up the graphs of sine and cos. So I'm going to really quickly do that. So here we've got cos of t, and here in green we've got sine of t. And so you can see very clearly that sine is ranging between minus 1 and 1. Of course, I probably should have labeled this point here as 1, and this is minus 1. But you can see very clearly sine ranges between minus 1 and 1, but cos is ranging between 0 and 1. Now, why was I able to apply sine to each part of this inequality, but not cos to each part of this inequality? The reason is that because in this region, sine is an increasing function. It's increasing, and so when I apply sine to an inequality, it preserves the direction of the inequality. But you can see that cos is not increasing. It increases here, but then it decreases in that region. And so I'm not able to apply cos to each part of that inequality because it's not an increasing function on this domain here. Okay, so we do have to be a little bit careful about that. And drawing up a graph is probably the best way to go with something like this if you're not able to just visualize it in your head. I know that I can't visualize these things. I have to physically draw them in order to see what's going on. But anyway, why is this important? Why was it important for me to determine the values that sine can take and the values that cos can take? Well, because for sine, I know that it ranges between -1 and 1. So if I add sine on, I'm able, like if I start with a 3, an x value of 3, I'm able to end up 1 unit to the right or 1 unit to the left. So I want sine to be part of my x parametric equation because it's able to get me to both sides. If I had cos in the x parametric equation, I could either only get these values here if I added on cos, or I could only get these values here if I subtracted cos. Okay, but I want to get both of them. So that tells me that sine needs to be in my x parametric equation, which means I'm going to eliminate options B and D. So now the question is, well, how do I determine if it's adding on sine and cos or subtracting off sine and cos? And to do that, I'm going to consider the range. So the range is running between 1 and 2. So if I start at 2, I don't want to add on values that go between 0 and 1, because if I add on values between 0 and 1, I'll actually end up with this part of my circle. I want the bottom half of my circle, so I want to subtract off values of cos so that my range goes between 1 and 2. So that tells me that I must have option C. Okay, let's move on to question 9. Which graph represents this function? Y equals the inverse sine of sine x. Now this is actually just simply coursework. I believe this is something that you should cover as coursework early on in year 11 when you do inverse trig functions. So you might be able to identify which one it is straight away. And that would be actually option A. So you might be able to answer this question in about 5 to 10 seconds if you know your coursework well. But how would you go about this if you didn't? Well, the very first thing I can determine is that option C is plainly wrong, because option C says that the domain of this function looks like, at least, something like minus pi on 2 to pi on 2. But that's not true, because I can plug in anything into sine, and then that will spit out something between -1 and 1, and then sine inverse takes anything between -1 and 1. So actually the domain should be all real x. So I can eliminate option option C. What about these ones here, B and D? Well, I know it's not D, and the way that I can tell this is because the sine on the inside has a periodic nature, and the periodic nature of the first function that, if you're thinking about this as a function machine, so you've got a function there, and you've composed them to get the overall function machine. So this first one here is sine x, and then this is the inverse sine. The very first function that our x values encounter is sine x, and sine x has a periodic nature. And because sine x has a periodic nature, that means our overall function is going to have some periodic nature, and D doesn't have a periodic nature, it's just a straight line. It's basically trying to say it's y equals x. Okay, so this one's incorrect. And then, well, okay, both of these now, A and B, have periodic natures. How do I determine which one's correct? And one way that you could do that is by having a look at the gradient of this thing, because you can see obviously their gradients are different. Okay. Also, another way that you could pretty easily determine this is that you can tell that this option B never has y equal to minus pi on 2, because on this line y equals minus pi on 2, or we've got our open circles. So this is telling us that y could never be equal to minus pi on 2. But you could probably find an x value that would give you minus pi on 2. For example, if I subbed in minus pi on 2 into this, I'll get y equals sine inverse of sine minus pi on 2. Sine is an odd function, so this gives me minus sine of pi on 2, but you don't even need to use the odd function actually. Sine of minus pi on 2 is -1, and inverse sine of -1 is minus pi on 2. Okay, and so this option would have to be incorrect. The only one that works is that point there, so option A is correct. Okay, if you wanted to do it using the gradients, and I might just show that method here, Where can I fit it in? I'll move this over here. If you wanted to do it using gradients, which is not a bad way either, it might just be a little bit longer, we differentiate to get the gradient function. That's what the first derivative is. And here I've got sine inverse of some function. So I have 1 over the square root of 1 minus the inside function, and then by the chain rule, I multiply by the derivative of the inside function, which is cos x. Okay, so I get cos x over the square root of cos squared. It's very tempting now to write square root of cos squared as simply cos, but it's not. It's equal to the absolute value of cos. And then the absolute value of cos is a piecewise function. So this breaks up into two pieces. It's cos x on cos x if cos x is greater than or equal to 0, or it's cos x on negative cos x if cos x is less than 0. And I'm just going to actually delete this now so I can fit this in. If we continue along, this gives us a gradient of 1 and negative 1, depending on whether cos x is greater than 0 or if cos x is less than 0. Okay. Now, let's think about it. Well, firstly, this is the only option which has the gradients of 1 or negative 1. But besides that, just for like our understanding, when is cos x greater than or equal to 0? Well, it's greater than or equal to 0. It's positive in the first and the fourth quadrants. So what's the fourth quadrant? The fourth quadrant is minus pi on 2 to 0. First quadrant is 0 to pi on 2. And now we've moved into the second quadrant, so I should be negative 1 gradient. Pi on 2 to pi is the second quadrant, and then pi to 3 pi on 2, that's the third quadrant. And now we go into the fourth quadrant, 3 pi on 2 to 2 pi, and so on. And so you can see this really does match up in terms of the gradients. And so option A is correct there. All right, last one. The members of a club voted for a new president. There were 15 candidates for the position of president, and 3,543 members voted. Each member voted for one candidate only. One candidate received more votes than anyone else, and so became the new president. What is the smallest number of votes the new president could have received? Okay, so this seems like a pigeonhole principle question, I think. Although you don't really need the pigeonhole principle to do it. You just need the logic of trying to spread things out as evenly as possible and then having leftovers that need to go somewhere else. So let's see. If we tried to spread out our votes as evenly as possible, what would we do? We'd say, all right, let's take this number, the number of votes, and divide it by 15 and see how many each person should get. So if I did 3,543 and I divided it by 15, I think I get 236. So I get 236, and which means I can write it as 236 times 15, but I'm left with 3 remainder. Okay, you get left over with 3 as a remainder. So what does this mean? This means if I wanted to try to spread out my votes as evenly as possible amongst all of the candidates, I would give each candidate 236 votes, so they're all even at the moment with 236, and then I've got 3 more which I still need to distribute. Okay. All right, so again, I'm still trying to keep it as even as possible. So I've got 15 people with 236 votes. Now, if I wanted to keep it as even as possible, I would give one of these 3 to 3 different people, except there's a problem with that, because then I would have 3 people, or let's say 3 candidates with 237 votes. And that's problematic because we're told in the question that one candidate received more votes than anybody else, which means that we do not want the winning person to be tied with anyone else. So how could we fix that? Well, we could give all 3 votes to the one person, in which case they'd have 239. But we want to try to find the minimum number of votes, the smallest number of votes that the new president could have received. So we still want to keep it as even as possible, but we still want there to be a winner. So how would we do that? Well, we would give 2 of these votes to someone and then 1 to another person. So we'd end up with having one candidate. Well, that's not how you spell candidate. Candidate would have 236 plus 2, which is 238. They're going to be the winner. So they'll end up being the president. Then I'll have another candidate who got 236 plus 1, because after we gave 2 away, there's still another one to give away. That's 237. And then the remaining 13 candidates, they're going to each have 236 votes. Okay, and so the minimum number that's required basically is like saying, how can we spread it out as evenly as possible while still having a winner? And in doing that, the winner would have 238 votes. So option C is our answer there. And that's the end of the multiple choice.